All right, now let us discuss about the derivative rules. So let's start with notations. So derivatives have different notations. For example, if y is equal to f of x, then for derivative we use different notation, f prime at x, or y prime, or dy by dx, or d by dx of a given function. These are similar notations. That means just to represent the derivative of a function. So please don't be confused if we use f derivative at x, or f prime, y prime, or dy by dx, or d by dx of f of x. So these are notation for derivative. Now we start with the constant rule. So constant function rule, constant function rule. That means if the function is constant, for example, if y is equal to f at x is equal to constant, then the derivative of a constant function is always 0. Let's use example. Find f derivative at x for f of x is equal to 3. Remember, f of x is equal to 3. 3 is a constant. Therefore, the derivative of this function is 0. That means, look at the graph of this one. The graph of this one is, a horizontal line. F of x is equal to 3. That means, remember, the slope of a horizontal line is always 0. That means derivative generally represent the slope. So the derivative of a constant function is always 0, or the derivative of a horizontal line, or the slope of a horizontal line, is always 0. For example, let's add more example. Let's say find dy by dx for y is equal to pi. Remember, pi is just a number, 3.14, right? So the derivative of dy by dx of y is equal to pi, it is 0. So y, the derivative is 0. Another one, for example, find d by dx of 23, for example. This one is just 0. Or C, find f derivative, find derivative of x for f of x is equal to 5/12. So look at this one is a rational number, which is a constant, so the derivative of this function is just 0. So the point now is the derivative of any constant function is 0. The second rule, power rule. Now the power rule, if y is equal to f of x, which is x to the n, where n is a real number, then f derivative at x is given by nxn minus 1. Take down n and subtract 1 from the exponent. Or also we can use, we can use this notation, which is nxn minus 1, and dy by dx is nxn minus 1. So we can use different notation for derivatives, so please don't be confused if we use one of the notations. Let us elaborate this one by example. For example, let's see, find f derivative at x for f of x is equal to x to the fifth power, right? Now, according to the power rule, f derivative at x, 5 down, x, 5 minus 1. This means 5x to the fourth. Let's see, this is A. Another example, find y prime for y is equal to x to 25. So y derivative is 25 down, x 25 minus 1. This becomes 25 x 24. Right, let's add more example. Find dy by dt for y is equal to t negative 3. Remember, the n is any real number, so dy by dt is equal to negative 3 down t minus 3 minus 1. This means minus 3 t2 minus 4. Or as a positive exponent, we can write this one also, negative 3 over t raised to 4 as a positive exponent. So both are correct answers. D, find d by dx of, for example, sometimes you may be given this way. This is rational exponent. So this means it is 5 over 3 down, x 5 over 3 minus 1. So this is 5 over 3 x, 5 over 3 minus 1 is 5 minus 3 over 2. This is 5 over 3 x over 3, this one, 2 over 3. So you can, the power rule is, it's a simple rule in derivative. So you can do it. For example, find d by dx of x 13. This is 13 x 12. Right? You can add more of the power rule, and we can write, for example, f. Let's see, find, let's say, f derivative at x for f of x is equal to 8x minus 4. So the derivative of this one is 8 times negative 4 x negative 4 minus 1. So this one becomes minus 32 x2 minus 5. That is as a negative exponent, or we can write negative 32 over x to the fifth power.